Good day, I'm Mr. Matthew, and the topic today is on Pythagoras Theorem. And the objectives as follow: to have the knowledge of what is Pythagoras Theorem, to be able to state the theorem, use the theorem, and understand some example that I'm going to do, as well as resolve some problems. Example, this is the theorem itself, say in the right angle triangle, this right angle triangle here, is right angle at C, this is 90 degrees. So it's right angle at C. So C here is the hypotenuse. You must know the hypotenuse. Say the area on this hypotenuse, the area here is C by C, that's C square. C square is equals to the square on this side, which is A square, plus the area on this other side, which will be B square. So this is the theorem. The hypotenuse square is equals to the square of this side plus the square of the other side. Here, we are at a first example. We are to calculate AD in this diagram, this AD. So you can see, this is a right angle. There are two right angle triangles here. The first one is this, and the second one is the bigger one. So we are going to deal with them one after the other. We take the first one, this, and we're able to look for DB. Once we get DB, then we can now look for AB. So the difference between them will give me AD. And here we go. So AD is equals to AB minus DB, just like as I've explained before. But in the first triangle, the biggest triangle, this one is 6, while this is 4. This is A, and this is D. To get this one, we use Pythagoras Theorem to be the square of 6, the hypotenuse, minus the square of 4, which will give me 16. Then it will be 20. Then the square root of 20 will be 4.472. So it's approximately 4.5 cm. That's B. That's a yes. That is that. Yes, that's AB. AB. That's AB. Then in the other triangle, we now pick the other triangle. Here is 4, and y here is 5. So using Pythagoras Theorem here, to be the square of 5, which is 25, minus the square of 4, and that will be root 9, and root 9 is 3. So here is 3. Therefore, AD, because this is D, and this is D, and this is B. So AD will be 4.5 minus 3, which will be 1.5 cm. 1.5 cm. Let's take another example. The sides of a rhombus are 17 centimeters long. If one diagonal is 30 cm, what is the length of the other diagonal? This is a wire question. This is the diagram here. The sides are all equal, as you know, rhombus. All are 17 centimeters each. You should know that the diagonals meet at 90 degrees. 30 is the longer one, So, and they will bisect each other. So here is 15, here is 15. So we call the other one we want to look for, we call it 2x. 2x. So here will be x. From here to here will be x. And y here is x. So it's 2x. We're looking for 2x. So picking one of this triangle here, it's a right angle triangle, we can get x. So the hypotenuse square, which is 17 square, which is 289 minus the square of 15. And that will be 225. The difference will be 64. And the square root of 64 is 8. So here is 8. X is 8. And we're looking for AC. Therefore, AC will be 2 times 8, which is 16. So that's the length of the other diagonal. Another example is this. Example 3. A chord 6.6 centimeter long is 5.6 centimeter from the center of the circle. A, calculate the radius of the circle. B, hence, calculate the length of a chord that is 6.3 cm from the center of the circle. These are the two questions. We draw the diagram. This is the diagram. This is the diagram. We are told that we call this from this center. The center is O, 6.3. It will bisect this chord at the middle. So N is the midpoint. So, and it's 90. It will meet at 90. So from there now, here is the radius. Here is also the radius. From the center of this one is 5.6. 5.6. So this, what we do, we pick in triangle AMO. AMO. Triangle AMO. This triangle here. Triangle here, because here is 3.3, because this is the midpoint of this chord. The chord is 6.6, so it will bisect it to here will be 3.3, and here is 90. Therefore, we can look for the radius. This is the radius, the hypotenuse. So the hypotenuse square, or R rather, will be the square root of the square of this, which is 31.36, plus the square of this one, which is 10.89, and the sum will be 42.25. Finding the square root of this will give us 6.5. So the radius is 6.5 centimeters. 6.5 centimeters. Now we are told to look for the length of this chord. This chord. We are told that from the center is 6.3. So we can get x. Here 2 will be x. Here is 2 is x. This place is x because it will bisect it. So we need to get just 1 first before we multiply by 2. To get this x here, this is a right angle triangle. This is a right angle triangle. So we know that the radius, we have calculated it to be 6.5. The radius is the hypotenuse in this triangle. Triangle CNO. Triangle CNO. So the radius square, that is 42.25, minus the square of this length from the center. And the square of that will be 39.69. The difference between that will be 2.56. And the square root of that is 1.6 centimeter. Now multiplying this one by 2 will give us 3.2 centimeter. So that's the length of the chord. So I'm giving you this assignment for you to do. It's taken from New General Mathematics, SS1. The first exercise is this. Exercise 11B, number 1 to number 20, on pages 135 to 137. While the second one is exercise 11C, numbers 13b to 15 on page 139. Now move forward on special angles. Special angles. The special angles are 45, 60, and 30. I come again, they are 45, 60, and 30. We are given a right angle triangle, isosceles right angle triangle. Here is 45, therefore here too be 45 degree. And here is already 90. So, of side 1 and 1. Here is 1 and 1. We can look for the hypotenuse using Pythagoras Theorem. So, the hypotenuse will be the square, that's x. X will equal to the square root of 1 square plus 1 square. And 1 square plus 1 square will give me 2. So the root x is equal to root 2. Root 2. So tan 45. Tan 45 from definition of tan that we have done. Opposite over adjacent. That will be 1 over 1. And it will be 1. Opposite over adjacent. That is 1 over 1. It will be 1. So tan 45 is 1. If you go to your 4-figure table, you will get that tan 45 is 1. So in a similar way, tan 45, it will be opposite, which is 1 over root 2. That's opposite of hypotenuse. Rationalizing this, we get root 2 over 2. Root 2 over 2. Similarly, for cos 45 is adjacent over hypotenuse, the same. So it's root 1 over root 2. Rationalizing that, we get root 2 over 2. So tan 45 and cos 45 are the same. So we can now use it to solve this problem. You should know that this one, we want to find x, we want to find the value of w, x, y, and z. So you should know that x here, this is an isosceles triangle, here will be 5. So you can find w, you square the other side, it will be 5 root 2. In a similar way, so that's why we got w to be 5 root 2. Since this, in a similar way, we can find the hypotenuse here is this. So we can use any of them, cosine or sine, to get the value of the next one. And we will have this one. So y and z are equal, and it will give us 7 over root 2. 7 over root 2. 7 over root 2. So you can use the hypotenuse is 7. Yes, the hypotenuse is 7. Hypotenuse is 7. 1, the 2, they are equal. So any one you are looking for. So, and this angle is 45. This is the opposite. So we have sine 45 is equals to y over 7. Making y the subject, you give me 7 sine 45. And sine 45 is root 2 over 2. Or simply 1 over root 2. 1 over root 2. 1, and therefore you have this. So your answer will be 7 over root 2. 7 over root 2. Therefore z2 is equals to 7 over root 2. Which can be rationalized. You can rationalize this one. When you rationalize 7 root 2 times root 2 over root 2, the answer will be 7 over 2 root 2 centimeter. This is another way you can express it. And move on. For tan, sine and cosine of 60 and 30, we take an equilateral triangle. You know equilateral triangle, all sides are equal. This time there will be 2 units. So here is 2. So since here is the midpoint, here will be 1, here will be 1. So we can find h inside this triangle here. We can find h. H is the height, the perpendicular height. So h here will be the square of the hypotenuse minus 1. And that will be 4 minus 1. So the height is root 3. The height is root 3. So now looking for tan 30 in this triangle, in that same triangle. Tan 30 will be this opposite. Opposite is 1. Opposite is 1 over the hypotenuse root 3. So we have 1 over root 3. For 60, this is the opposite and this is the adjacent. So it will give me root 3 over 1, and that is root 3. So tan 60 is root 3. For 30, let's go to sine 30. Sine 30, this is the opposite. Opposite is 1. And the hypotenuse is 2. So it is 1 over 2 half. Similarly for cos. Cos is adjacent, which is root 3 over hypotenuse. It will be root 3 over 2. Now for 60, this is the opposite. For sine 60, opposite root 3 over 2. So it will be root 3 over 2. And lastly, cos 60, it will be adjacent over 2. That is 1 over 2. So you can see that cos 60 is half. So we can use this one to solve this very problem. And you will have this. In the first triangle here, the opposite is 3. And the adjacent is A. You can find A using tan. When we use tan, we will get A to be 6. And that of B will get you to be 3 root 2. 3 root 2. Similarly, in the second diagram, we can as well use sine or cosine to get C and D. And we have it as follows. C is 4 root 3 and YD is 4 centimeter. Lastly, in the last triangle, you know here, you can use any of the trigonometric ratio to get it. This is opposite over this. You can use tan and you get x, tan 30. And we have x to be 5 root 3 centimeter and y is 10 centimeter. That's the solution. Another problem, we have to look for AD here. This AD is the hypotenuse of this triangle. But here, we are given here to be 4. So we can look for AC first. So this is the opposite. We want to look for AC. Once we can get AC, then we can get this. This is the opposite to 60. Opposite over adjacent, that's tan. So we use tan 60. From tan 60, we get here to be AC to be root 3. We get it to be 4 root 3. 4 root 3. And if here is 4 root 3, we can now find this other side, either by Pythagoras Theorem or any one. We could get here. We use sine. We know that sine 45, then we multiply by root, and we now have this. So AD is 4 root 6. 4 root 6. Another example is this. We want to look for PQ here. So we can get here first. Once you have gotten xy, using, here is 24, yes, since this is angle 45, here, from there now we can calculate here. This will be opposite to find here, opposite over, that's tan. So we use tan there. We now have, that's why this is 24, you can see xy is 25. Then the other point, SQ, we have it to be 8 root 3. 8 root 3. So the difference between here, 24 and 8 root 3, this is 8 root 3, 8 root 3. So the difference between them will give me PQ, and that is 24 minus this. Factorizing, or you leave it like this, when you factorize, 8 is common. It will be 8 into 3 minus root 3 centimeter. Another example is this. You are given that sine x is 5 over 13. Find the value of tan 1 plus tan x over minus, here is minus, I'm sorry. Here is minus, or minus. So we need to get tan. We use Pythagoras Theorem. We use Pythagoras Theorem. We use Pythagoras Theorem to get this height, y, and y is 12, because it will be hypotenuse square, that is 169 minus 25, and that is the root of 144, which is 12. Now, tan x, opposite over adjacent, which will be 5 over 12. So substituting the value of this here, and there we have this, and this will be 17, the up will be 17 over 12, while the lower one is 7 over 12. Because we are dividing, we change it to multiplication, it will be 12 over 7. And multiplying that, we have 17 over 4, because 12 we cancel 12. 17 over 7. And that will be 2 whole number, 7 over 3. That will be the value. We move over to another example. A town is 61 kilometers north and 23 kilometers east of town B. Calculate the bearing of A from B to the nearest degree. So we are given the bearing of A from the north of B. We are given the bearing of town A. Town A is east of B. Town A is east of B. And that's why we can see, north of, you move to A. This is 23 kilometers. And why the distance from AB is 61. So this is the bearing of A from B. So here, we discover that tan x opposite over yes. We have it to be, okay, this is 61, sorry. This is 61 kilometers. So this is the opposite, and this is 61. So tan x is 23 over 61. So getting x, it will be tan inverse of 23 over 61. And that will be 20.66 degree, approximately 21, to be the bearing. So this angle is 21 degree. That's the bearing. Now I have another example dealing with angle of elevation. The angles of elevation of the heights of the highest point of a building from point X and T are 60 and 30 respectively. T is vertically above X and ST is 10. Calculate the height of the building above the level of X. This is a wire question. So this is the tower, 10 meter. So here 2 will be 10 meter because this is a rectangle. But this is the angle of elevation from the bottom as well as the top. Now this is 90 degree. This is also 90 degree here. So we call here X. So we'll call this distance from here to be D, the same distance here, because it's a rectangle. So when we look for D here, we get D to be, using tan 30 in this triangle. So you get D to be X with 3. Then in the other big triangle here, so tan 60 will be this over this. So we now have this D to be this one. That is D equals to X plus 10 over root 3. These two are equal. Equating equation 1, we now have 3x equals to X plus 10. Making X the subject, we now have 3 minus X, which is 2, equals to 10. So our X is 5. So the height here is 5, X is 5. Therefore, the height is 15. The sum of this, 15. So that's the height. So I'm giving you this one as an assignment to classwork. Exercise 11E, numbers 1 to 20, same New General Mathematics SS1, on pages 143 to 144. The last exercise is exercise 11D, numbers 1 to 27, New General Mathematics SS1, on page 142. So I wish you the best. Have a lovely day. Thank you. We'll meet again on another topic. God bless you. The weekend assignment will be sent to you as well.